Okay, so this is my latest project. I had a computer programming class where I learned to use the Python language, and for the final project we were supposed to do something with it. I built this thing. It was supposed to be a laser burner, like one I found on Instructables, but I didn't get the laser parts in time, so I still have the laser, but I don't have the driver for it yet. I'll post a new video when I get that, but for now I've got a pen, or a mechanical pencil rather, and see, this thing doesn't really have a macro mode, so bear with me. There we go. So it's drawn a Christmas tree. That's just sort of the first program I did with it. And to hook up the stepper motors, which I'd never really done anything with before, I used these Easydrivers. Now the SparkFun website was on back order when I went on, so I went to eBay and got them there. And they didn't come with anything telling me how to hook them up except for some silk screening on the board, so I had to go online and figure some stuff out. But I found that this little contact near the bottom, or these two contacts where it says 3/5 volts, if you jumper those, it'll respond to lower level signals, or lower voltage signals, which was necessary in my case. And I'm not quite sure why, because this LED apparently requires a resistor. I hooked it up where I'll be hooking up the laser eventually. It apparently requires a resistor, but then I had to turn the sensitivity up on this. I don't get it. Anyway, that helped, and also from Instructables I saw you should hook up the plus 5 volt to MS1 and MS2 for microstepping, so I did that on both. The other connections were fairly straightforward. You've got power up here, you've got your power output down here, so you've got a ground step function and a step signal and a direction signal, and those are just simple on-off signals. And then you've got your power connections to the motor up here for the coils. You can tell those easily with a voltmeter. Just, you know, if two pins are together, that's either coil A or coil B, and it doesn't seem to matter which one is which. And yeah, I turned the potentiometers up just a little bit because they were at their minimum setting, and they seemed to be having a little trouble dragging the pen around. But yeah, it was pretty much the extent of what I had to do there. The motors themselves I just soldered up with some ribbon cable and ran that around in kind of a mess, but I was lucky enough to find a parallel port end piece that had serial cable on it, and I just soldered that to the board. Now, I got kind of a weird cable. I thought it was just regular cable, but as you can see I had to do some splicing on it. All the pins that are blue have no connection through the cable, and most of the rest of them were jumbled. I know there's some logic behind it. It was for like a quick transfer protocol or some crap, but yeah, it was not what I expected and not helpful. I just kind of found the cable though, so I can't really complain about it. So I just chopped it in half and then resoldered the connections so that they're straight, but I'm still minus 3 functions and a whole lot of grounds. The grounds don't worry me because I can just use pin 25, which is apparently a universal ground, but the 3 extra functions would be nice to get, and that's as easy as getting a new cable, so I don't sweat that too much. It was a little difficult to find a computer that still had a parallel port on it. My MacBook sure as hell didn't. So I used this old Dell that was my dad's and had been running at about the speed of smell. Part of that's because it's old, and part of that's because it was on XP, but also I went to start run and then typed in msconfig, and that allowed me to tell it to adjust for what was it? Performance rather than for visuals. So it made everything look kind of like it's Windows 98, but it runs so much better than it did. It still crashes a little bit, but for this, at least, it's brilliant. Yeah. So, the programming. I don't actually have a system to do screen captures into this, but just kind of go through it. Basically, I import parallel which is a module. It doesn't come with Python, you have to download it separately. And sleep, the sleep function from time, which is also useful, as I'll demonstrate. And what I'm basically doing is I can output in byte strings. So it's 0B and then 8 digits that are all either ones or zeros. And 1 or 0 translates to low or high on the outputs. And so the first 3 are the ones that I don't have, and then the next one would do the laser, and then I've got step Y, which, I just called it that. It's not like its system name or anything, but that makes the Y motor step. The next one controls the Y motor's direction. On is one way, off is the other way. And then I got the same thing for X. And I figured out that the table is about 1900 steps square. I did that by writing a function that just moved it until I told it to stop, and then that told me, it popped up and said, that was this many steps. It was like 1960 or something, so I decided 1900 was safe. And I've set a time variable to 0.001 second, which that was just a trial and error thing, but it's a lot easier to trial and error it when it's up here and I don't have to change it in all my functions. One of the greatest bits that I learned how to do was to write functions, because it means you don't have to write the same code over and over again. And for controlling these, I decided to give them compass directions relative to the pen. So making the pen move or draw that way is north. And to the motors, north means that this motor moves the tray back, or I guess towards me, which makes the line go up it. Anyway, if I don't think about it too much, it works wonderfully. But so I've got my function for north, and let's see if this will help. There we go. So I got my function for north. The def just means it's a function. I pass it distance, which is an argument, or it's just a number. I give it a number for distance. And where it says works, that's just a note I was going through and troubleshooting. And while distance is greater than 0, every time it goes through, it subtracts 1 from distance. That's the distance equals distance minus 1. And so when it gets down to 0, it calls the function done and over with. And so what it does, where it says par.setData, the par basically means parallel.parallel, and I didn't want to type that out a whole bunch of times, so par works a whole lot better. Set data, and then you can see I've got 0, 0, I got 4 zeros, 1, 1, 0, 0. That gives a signal to the stepper to the step pin for the y-axis and to the direction pin on the y-axis, and nothing to the x-axis. So that just moves y backward. And then it sleeps for that time interval, and then it sets everything back to 0 except for the direction, which I found doesn't like to be pulsed. It gets confused. So I just leave that on. But basically what this does is it makes the step pin pulse that many times with the direction set, and then it just loops through that while the while statement is true. And it goes through that, and then I've just got all my other functions. And I set up specialized functions for diagonals. I've got, southwest, northwest, and then I've got some longer ones for slightly longer ones for different diagonals, like south, southeast. It's a little longer because it's basically telling it to go southeast and then telling it to just go south. So it goes southeast, it goes south, it goes southeast, it goes south, and at this size and with the steps as small as they are, it works just fine. So this is my program that made the tree. So rather than telling it to send this message to the chips and programming it on that level, I'm just telling it go east 800 steps, go north 250 steps, go east 190 steps, which isn't too unlike the Python Turtle utility, which is just a 2D graphics engine.